Now, I'm going to go ahead and record this just so that we have a video for other people that are not going to be here. And they'll be able to get this information too. Okay, I'm going to go ahead and I'm going to stop pacing for a second and we're going to be going on. So I'm going to move you over here to this guy. We're going to be doing what's called What's in My Bag. So this is going to be a little bit of a participation by you guys, and you're going to figure out what's in my bag. Now, if you want to use your calculator, you are more than welcome to do so. Okay, you can do that. What you'll need to do is maybe split screen it, or you can use the Desmos calculator, whatever. But you're going to be determining how many of certain items that I have in my bag. Okay. All right, here we go. Moving on. Here's my first question. It says, in my bag, I have 8 colored coins worth $10. The yellow coins are worth $1 and the orange coins are worth $2. How many orange coins do I have? So there's a little box down here in the bottom that you can use to type in your answer. So go ahead and see if you can figure that out. Now, one thing you might think about is this. So I'm going to go ahead and write on my screen so this might help you out. I have 2 types of coins. I have yellow coins and I have orange coins. Okay. I have a total of 8 coins. So the number of my coins has to add up together to be 8. Now, my yellow coins are worth $1 and my orange are worth $2. The total sum of those guys is going to be my $10. So your job is to figure out how many orange coins I'm going to have. How many orange coins I'm going to have. So let me give you another example. Let's say I give you, let's split it up, right? Let's do 4 yellow and 4 orange. 4 yellow and 4 orange. Okay, well, 4 times 1 is 4, so that's $4. And 4 times 2 is 8. That's $8. But 4 plus 8 is not 10. So in this case, that's not going to work. So we can't use 4 and 4. How many orange coins do I have? All right, so I'm seeing a lot of good numbers. I'm seeing a lot of 6s and I'm seeing a lot of 2s. So let's talk about this again. Most people are saying 6 yellow and 2 orange. So 6 plus 2 is going to give us that 8 right there. That's awesome. Okay, cool. Then we come down here and we say, okay, well, 6 times 1 is $6. And 2 times 2 is $4. So yeah, 6 plus 4 is going to give us our 10. Now here's the thing. I'm wanting to know orange coins. So I want to know this one. So if you put 6 on there, you've got part of it right because yes, we do have 6 coins for one of those colors, but that's for the yellow color. So you want to make sure that you're answering the question and doing it for the orange color. Okay, doing it for the orange color. Okay, Sweet. I'm going to send you guys over here to this next page. Now, what I want you to do is I want you to scroll down. Do you notice something? Huh, interesting. So I've got a picture from a calculator. It has 2 lines on it, and then it has that same 6 and that same 2. Interesting. Very interesting. Okay, moving on to the next question. Keep all of those strategies in mind. Here's my next question. I have 10 coins in my bag worth $1.90. Some are quarters and some are dimes. How many dimes do I have? I'll give you a second. All right, once you've got your answer, if you'll go ahead and type it in. Okay, now you also have to remember, guys, remember, you can only have 10 coins. All right, so if I set this up, I have quarters over here and I have dimes over here. Quarters are 25 cents. Dimes are 10 cents. I can only have 10 coins. Now, let's say I started with just like the middleman. Let's say I start with 5 of each. So if I take 5 times 25, that's going to be $1.25. If I take 5 times 10, that's going to be 50 cents. So then when I add these two together, that's going to end up giving me $1.75, which is not $1.90. So 5 dimes or 5 quarters is not going to work. So we can't use that one because it's not going to give us our actual answer. So let's not do 5 and 5. Now, some of you guys are giving me some answers like 6 dimes or 5 times. 6 dimes would end up being 60 cents. If I were to take that from $1.90, that would give me $1.40. No, 30, excuse me. That was terrible. Let's not talk about it. $1.30. Can any amount of quarters give me $1.30? No, right? Also, when you're doing these problems, you can't have half a quarter, right? You can't take a quarter and cut it in half. Because if I take a quarter and I cut it in half, like, then is it still a quarter? Also, think about this. What if I had 7 dimes? Okay, well, 7 dimes is 70 cents. That's awesome. Okay, but $1.90 minus 70 cents is going to be $1.20. I don't think there's any amount of quarters that you can do to make that up, because even if I did 5 quarters, that would be $1.25, but not $1.20. Also, 5 quarters and 7 dimes is not going to be 10 coins, so it can't be that. Okay, I'm going to move you on to the next page. And let's take it down here to the bottom. So scroll on down on your page, and I want you to look at the graph. If you notice on that graph, do you guys see it? Here's our answers. We've got 2 lines and they cross and they give you your answers to your system. You've got your 4 and you've got your 6. So in this case, if I'm trying to find out how many dimes I'm using, then the correct answer is going to be 4, because my dimes are going with my x in this one. Guys, this is systems of linear equations. This is what we're going to be studying next. Okay, another one. Keeping that knowledge that you just did, keeping it in your brains, go ahead, try this next one. Okay, now remember, I have 10 tickets. So 2 tickets plus another 5 tickets is only going to be 7 tickets. So I've got to have a total of 10 tickets. Okay, so another way you might think about this as you're trying to figure it out, you have adult tickets and you have kid tickets. They have to add up to be 10. Adult tickets are $5. Kids tickets are $2. And the total price of all of the tickets combined is $41. So again, you're trying to figure out how many kids tickets and adult tickets do you have, specifically how many adult tickets. Now we can try 5 and 5. If you were to try 5 and 5, it would look kind of like this, because 5 plus 5 is going to give us 10. So that's the easiest one to figure out. Now, 5 times 5 is going to end up being $25. And 5 times 2 is gonna end up being $10. So 25 plus $10 is not gonna give me $41. So I wouldn't put 5 adult tickets because that's not gonna match. All right, good. Okay, so I see somebody with this one. So I'm going to go ahead and I'm going to show this one. They said 8 tickets. So if I did 8 tickets here, then that means I'd have to have 2 kids over here. So 8 times 5 is 40. And 2 times 2 is 4. So it wouldn't be 8 because that would end up being 44. End up being 44. All right, awesome. I'm starting to see a lot of good work over here. Very nice. All right, let's take it, let's scroll it down. I'm going to show you guys. Take a look at that one right there. We've got 3 and we've got 7. And so our adult tickets is going to have to be 3. Sophia, that wouldn't work just because that total is not 10. Because you have to have 10 tickets. All right, good work, everybody. So guys, essentially what this is this is called systems. This is systems of linear equations. And again, we're just looking at like what they look like and how they can help us. So if you scroll on down on that next page that I just sent you to, you're going to see the graph of our systems. Now, I will eventually teach you how to write systems, but we're not going to focus on that today just because we don't have time. Okay. So let's see here. Just a second. Okay, I'm going to move you guys on to our next page. Now, I'll make these notes available to you guys online. So if you'll just go ahead and copy them down right here, that'll be the easiest for you. Okay, so again, I'll make these available to you online so they're not just in the decimals. I just want to give you guys practice. Okay. So we have a couple of types of systems that we're going to be studying. Essentially, our system of equations is going to be 2 or more linear equations with the same variable. Ooh, that looks terrible. Oh no. Oh no. Oh no. Look at that, y'all. That's tragic. There we go.
That happens to me. Don't worry, miss.
Oh. This is the only bad part about Desmos. Like, it has other good things, but it's not super great on this one. It's like I want to zoom in, but it like doesn't, it's not like Notability. It doesn't like, it doesn't change things for you. Ugh. I just, nice, Parker. Ugh, these look so gross. Like, I just don't like them. Hold on. Okay, I'm not feeling it. Are you guys feeling it? I'm not feeling it. Okay, I'm going to change it up a little bit. Hold on. Give me a second. Okay. Okay, hold on. In a momento. I'm gonna have you guys download a couple of pages. Oh. Hold on a second. Sorry. Hold on, kiddos. I'm gonna have you guys download like these next couple of pages. It's just gonna be easier, and then I'll try to do it on my board, or I'll do it on my iPad so you can see it a little bit better. I just don't like the way this is showing up on our Desmos. So give me a second. Okay. My computer's taking 1,000 years to load. I just want to go really fast through these, and it'll just be easier if I do it standing up and showing you guys than the current process. All right. Okay, I'm gonna have a couple pages for you guys to download. It's gonna seem like a lot just by looking at it, but it really isn't that bad. All right. Export. PDF. Okay. Here we go. Sorry, this is so boring, y'all. I'm just struggling here. Struggle this moment. I'll get it together. Okay, will you guys give me a thumbs up when you've got this, when you've got those 3 files? Thank you, Andy.
What is it called?
So it's the 3 files underneath where it says Desmos. It says systems, notes, foldable, solve systems by graph and a table practice, and then solve systems calculator. So it's like it's like 5 pages total. Awesome. Go ahead and let's get started. This is not going to take very long. I promise you it's super easy. Maybe 10, maybe 15 more minutes. I do want to show you a couple things in the calculators. But I just want you to guys to have this stuff written down. Okay, so with our systems, we have systems of linear equation. It is 2 or more linear equations with the same variables. So it probably is going to, you're going to see it something like this. Maybe 2x plus 3y equals 10. And maybe 5x minus 2y equals 15. That is a system. It's got 2 linear equations, but the variables are x and y. The way that we're going to solve these is going to be by graphing, by substitution, elimination, with a table, and with a calculator page. Now I can tell you right now, this is going to be your best friend. This calculator page is your best friend. Now, I used to think that the graphing was going to be my best friend, and it used to be my best friend, and I'll show you how it can be your best friend. However, because of our calculators and the fact that a lot of these things are going to be in standard form, it's not going to be ideal for you to use that. Instead, you're going to want to use your calculator page. Now, substitution and elimination, those are also some things that we're going to be learning this year, but I'm going to touch on them. I'm not going to spend a ton of time on them. Because you have your calculator, but you will see it again in Algebra 2. And your Algebra 2 teacher is going to be like, didn't you learn substitution and elimination in 9th grade in your algebra class? And you'll be like, yes, we did. We talked about it. We did a couple. However, my teacher said we had bigger fish to fry. Okay, because we do. We've got a lot of stuff to cover. So substitution and elimination is not going to be our key focus. I will show you how to do it. It's not going to be crazy though. Okay, you got your calculator page. More worried about that. So let's take a look at this very first type of system. Okay, the very first type of system is going to be kind of like what we did with what's in my bag. It's going to be determining one solution that's going to work. Just like I can only have 7 orange coins and 3 yellow coins in my bag. This is going to be our intersecting line. So I'm going to come over here and I'm going to write intersecting like this. Intersecting lines have one solution. They are labeled X and Y. Facts about them are they have a different slope and a different y-intercept. Now, sometimes you might have the same y-intercept if the lines intersect on the y-axis, but most of the time you will not have the same y-intercept. Next, we have our parallel lines. Parallel lines do not have a solution. They are considered a no solution or an empty set. Main reason for that is because they will never touch. They have the same slope, but different y-intercepts. So I have a joke for you. Why can parallel lines never date? Anybody know?
Why?
Because they'll never meet. Thank you.
I don't get it.
Well, if they never meet, can they date?
No, now I get it.
Okay. Yeah, I got some smiley faces. Oh. Here's my other math joke for you today. Without geometry, life is pointless. Because geometry, points, lines, and planes. Oh, yeah. Got my math jokes on. Thanks. All right, last one on here. Last one on here is going to be infinite solutions. Infinitely many solutions, or all real numbers. They have the same slope and the same y-intercept. So pretty much they're the same line. We call this coinciding lines. They're coinciding lines. All right. So I just want you to I don't care where you do this, if you want to do it on another page, I just want you to see what they look like. So I went ahead and I drew them down here. And again, this was a foldable for us. So this is what our foldable looked like. So our intersecting lines looked like this. They had one solution. So if you want to add a page and jot those down, you can. Intersecting lines have one solution because they only meet in one spot. Parallel lines have no solutions because they're never going to meet or touch. And then coinciding lines, they're the same line, so it's really hard to tell, but they have infinitely many solutions. Okay, give me a thumbs up when you're ready to go on. Okay, don't worry, I'll be posting these online, so you'll have a copy of them so you can check them out. But let's go ahead and let's go on. Sorry, not that page. Let's go on to our first page. All right. Ooh, it looks crazy. It looks crazy busy. However, don't freak out. Okay. Don't freak out. These are all STAR test questions. These are how you will be tested in terms of systems. Okay. So I wanted you guys to get an idea of what they look like. I promise you it's really easy. The first one's the hardest. I am going to show you some calculator stuff really quick just with this first one. The other ones actually don't require you to use a calculator at all. Okay. So let's take a look at this first one. Okay. It says which system of two linear equations and two variables best represents the graph? So here's what you guys have to do for this first question. One, you have to graph them. Oh, can't spell today. You're going to have to graph each of them. Then what you're going to be doing is you're going to be pressing menu. You're going to analyze graph. And then you're going to do intersection. You're going to be clicking the left side, then the right side. So let's take a look at this picture over here. You know it's a system because it's two lines and they intersect. How many solutions does this system have? Any? How many solutions does this system have? Look at your picture. One solution. Very good. So if I come over here, I'm going to go ahead and put a dot where my solution is. I'm going to draw a line to it. Now, what would be the coordinates of this point right here?
2, -5.
Perfect. 2, -5. Awesome. So those are the coordinates. Now, what we're going to do is we're going to look at each answer choice and we're going to graph them and we're going to decide which one of these points is going to have a solution of 2, -5. Okay, so here's what we're going to do. Go to your TI Nspire. And we're going to graph this. Okay, so make sure you're on a graph page. And I want to show you a couple of things. I'm pretty sure that you know how to graph stuff on here. However, I want to make sure you know how to use the intersection tool. So the first one we have is A, it's y equals 3x minus 1. So we're going to type that in, 3x minus 1. I'm going to click enter. There's my first line. Then I'm going to click the plus button over on the side, and I'm going to type in the second equation. 3 divided by 2. Scroll over, put in an x minus 4. Click enter. Now, if you're at school and you're using our calculators, you'll see a part of this. You won't see all of it. But guys, does this match our graph that we have going on over here?
Nope.
Nope, it sure doesn't. So this is not going to be our correct answer. So we're going to get rid of this answer choice and we're going to move on to our next answer choice. We got our B. So I'm going to click add. I'm going to click graphs and I'm going to type in that next one. So we've got y equals -3x plus 1, enter. We hit the plus button over on the right-hand side and then we type in 3 divided by 2, put your x, and then minus 4. Enter. Now that looks very close to what we got going on over here. However, I don't necessarily know for sure. So here's how you find out for sure. And then this is the new part. This is the part that I've never taught you. You're going to go up to the wrench button. You're going to go down to analyze graph. And then you're going to click intersection. Now at the bottom left-hand corner, it says lower bound. That's the left side. So my lower bound's over there. And then I'm going to click on the right side of my function. Oh, come on. Why is you doing this? Hold on. Let me try it again. I'm going to click over on the right side of it. Why is it not doing this? There we go. Now, when I click on the right side of it, it's going to automatically find the intersection of those two lines, which right now is at 1.11, comma, -2.33. So because it doesn't say our 2, -5, our answer B is not going to be correct. So we're going to move on to the third choice, answer choice C. Here we go. I go to graphs. I type in our C, 3x plus 1. Click enter. Click the plus button, 3/2, x minus 8. We click enter. All right, so looking at that guy right there, it's not going to work because we definitely know that it's not going to be intersecting on that side. Now with the app, it's really nice because you can kind of zoom out and see it a little bit easier, but just know you're not going to be able to do that on our school calculators, okay? All right, so we obviously know our answer choice is D. Let me go ahead and let me show you our answer choice D. I think I already had it over here. Here we go. This is what this would look like if you were doing answer choice D. You still do the intersection. Again, that's the tool. We take analyze graph and then we do intersection. You click on the left and then you click on the right. Oops. And it'll give you that 2, -5. Now again, I'm not spending a whole lot of time teaching this because guys, actually this question, all of those answer choices were in standard form. It would take a lot of work to take those and to make them into standard form. So I'm not going to teach you guys that today. I'm going to teach you guys another way. Now on your Delta Math, there are 3 problems where you actually have to graph them. But there's just 3 of them. Everything else is going to be using our calculator. Okay. All right. So let's take a look at the rest of our problems. Again, these are going to go by, it's going to go by really quickly because I promise you it's super easy, this next part. All right, question number 2. And again, you can go ahead and mark that here. Grab your highlighter on your notability. Okay, number 2 says, the graph below shows the distance that car A and car B are from Dallas over a 5-hour period. Car A is driving towards Dallas, whereas car B is driving away from Dallas. Based on the graph, how long will it take before the cars are the same distance? So here's what I need you to do. Take your highlighter and I want you to highlight how long. How long is this going to take? Okay. Now, your goal in this is to make sure you're reading the question correctly and you're reading the graph correctly. So take a look over here at your graph. As you can see, this is a systems because I've got 2 lines and they're intersecting. So go ahead, take your pen, and I want you to put a dot at your intersection. That intersection is going to be our solution. Again, you didn't have to put this in your calculator, you're just graphing it. All right, the coordinates of that solution is going to be over 2, up 20. Now your goal is to figure out what each of these things mean. So grab your highlighter and let's go ahead and let's highlight our X values. So our X's are going to represent the time driving in hours. So I'm going to come over here and in parentheses, I'm going to put hours. Can't type today or write today. I'm then going to go over to my Y's and I'm going to highlight my Y's. My Y's is talking about distance in miles. So 2 hours and 20 miles is going to be my solution to this system. So then you ask yourself, based on the graph, how long will it take for this system or for the 2 cars to be the same distance? Since we're talking about the length or like how long it is, how much time, we're going to be talking about hours. So when you look at these problems, you can come over here and you can get rid of miles because that's talking about distance and just look at hours. So in this case, looking at our hours, the only correct option we've got is going to be answer choice C. Now, does anybody have any questions about that? Okay, it's not super crazy. It's not super duper hard. Your job is just to make sure you're reading the question correctly. Okay, so I'm going to go ahead and I'm going to help you again with this next one, and then I'm going to let you do the next one by yourself. It says the cost of renting a cab at the yellow cab company and the blue cab company are shown on the graph below. At approximately what distance traveled in miles would the cost be the same for each cab company, and what would be the approximate cost? So grab your highlighter. Go ahead and highlight the distance. So approximately what distance and approximately what cost. So that's going to be something that we're going to need to know. Distance and cost. Go over here to your graph and I want you to highlight your X values and highlight your Y values. And then I like to write them out. So since my X values are miles, I'm going to put that first. And then my Y values are cost. So I'm going to put that here. So go ahead, take a second and see what you think. Does anybody know our solution? Luke, can you tell me what our solution is?
I'm kind of confused.
Okay, so taking a look back up here on that one, you see it? What was our solution for this one?
2 and 20.
Okay, and why did we choose that one as our solution?
Because like that was the X and Y values.
Right, of where the lines cross, yeah?
Yeah.
Okay.
Oh, so that's what I'm gonna tell you is that?
Yep.
Okay, so it's 3 and 8.
Perfect. 3 and 8. So now guys, really quick, based off of that, 3 and 8, which answer choices can you get rid of? Shout it
BC.
out. B and C. Bye, Felicia. Bye, Craig. Don't use those ones because they don't have the right numbers. Okay, now look at this, guys. Miles went with my 3. I'm gonna use a different color and highlighter. Money went with my 8. So is this going to be A or D?
A.
D.
It's D. Here's why. Money goes with the 8. So if you look over here, this has $8, whereas this one right here has $3. So our correct answer,
I just bamboozled myself. I got confused.
do you understand now?
Yeah.
Okay. Okay. Here's what I want you to do. Go ahead. Do number 4 for me. Do number 4. All right. Anybody think they got the correct answer? Got it. Andy, what do you think?
C.
Yes, the correct answer is C. Okay, let's take a look at it. So what we're trying to decide is how many lawns, so I'm going to highlight this, how many lawns will Larry have to mow before he starts making a profit? So we come over here. Our number of lawns is our X and our money is our Y. So I like to write that down. So these are going to be our lawns here and our money is going to be over here. Now, what you have to do is you have to find that solution, which is going to be right here. Now, I know it's not on a pretty point, so you kind of have to take an estimate on it where it is, but that's going to go down and that's going to be our 25 for our X. And then we're going to come over here and that's going to be our 350 for our Y. Okay. So if we're talking about our lawns and the number of lawns, well, then we don't need our 30 and we don't need 35. And we know he's not going to make it a profit on the second lawn he mows. So it has to be our 25 lawns. That's how many lawns that he has to mow before he can start making profit. So if he mows 26 lawns, then he's going to make a profit. So that's why we don't choose our 30, is because he just needs 25 lawns to make that profit. Okay. Now, these next next 3 problems are super easy. I don't want you to read them. I want you to think about it. Just take a look. See if you can figure out where my solution would be. Where do you think it's going to be, guys? Anybody take a guess?
What the answer?
Well, not necessarily the A, B, C, or D, but like, where do you think it's going to be in my table?
Maybe number 3.
Okay, so you're thinking like right here? Right there? Nope, not quite. Anybody else take a shot at it? Okay, so think about this for just a second. In order for something to have a solution, so for this guy to be a solution, they share something, right? They cross and they share this point right here. They share it. That's why it's called a solution. So they have something in common, and that something in common is that point. So take a look back at again at that table again. What point do they have in common, guys? Ian, can you take a guess? What point do they have in common?
Two.
No, they don't have that point in common. Here's why. Because if I did a 2, then one of them is going to be at 24 and one of them is going to be at 60. Good thought, though.
It's 8 because there's 96.
Yes, perfect. Everybody grab your highlighter. Anytime you're finding a system on a table, I want you to look for where they have the same point. So grab your highlighter and I want you to highlight right there. Does everybody see how they both have an 8 and they both have a 96? This is going to be where your solution is. Again, I didn't read anything. I just looked at my table and I found out where they had the same part. So I will go ahead and I'll read this. Blue Lake is Pat's favorite place to swim during the summer. There's an entry fee of $12 per day. Pat notices a sign as they approach the entrance. His family could join the Blue Lake Club for the summer. The summer prices cost $48 to join, and then the entry fee becomes $6 per day. How many days can you go to the pool for both of the options to be the same amount? Again, keyword, same amount. So we're looking for 8 days, okay, because our days are over here. And then our 96 is going to be our fee. So let's take a look at B. What's wrong with B?
There's
It doesn't
not
have the
8
right
or
numbers.
Yeah, they don't have the right numbers. Perfect. You got a 3 and a 66. Also, look at D. The membership fee does not charge an initial fee. Well, that's not true. So we get rid of that. So here's going to be the problem for you guys. Is it A or is it C?
A.
Perfect. Look at C. It says $8. That would be really silly for our total option to be $8. So it's not going to be C. It has to be A. Okay, so here's what I want you to do. I want you to take a look at these next 2 problems, and I want you to see if you can figure out the answer to those next 2 problems. Ready, set, go. All right, let's see if we can answer this. Okay, Parker, can you tell me what you got for number 6?
I got B.
Perfect. It is B. So look at this last part of the question. It says, what time will Max and April's trip cross? So what time? So we're talking about time here. And then we're going to be looking for the parts that are the same. So if you notice, you've got 3 and 2:30 over here. You've got 3 and 2:30 over here. Now, people make this mistake. They won't choose the 2 hours. They won't choose this guy right here. But this is what will happen. They'll choose this because they're thinking, oh, 2:30, it's the same. But you guys have to be better than that, and you have to know it's talking about time. So we shouldn't be talking about miles. We should be talking about time. 2:30 is the miles. Yes, that's correct. However, it's not answering the question that they're asking. Okay, number 7. Auntie, what'd you get for number 7?
C.
Perfect. C. Boom shakalaka. So we come over here, we highlight where they're the same. And then you have to ask yourself, okay, what's the question asking? And it says, when will? So when will is talking about time. So what year are they going to be the same? So we're looking at year 240. So we're not looking at 517 athletes. Year 517 is just silly. And we don't have 2040 athletes. So our correct answer has to be C. Okay. So overall, that is our systems with graphs and tables. Again, we won't be using a lot of them, but your STAR test will have a lot where you're not having to graph them in the calculator. You're mainly just looking at the graph and interpreting them. Okay. All right. So this last thing that I'm going to show you, again, it's super easy. And it's going to be how you solve like 90% of our systems. This is what your Delta Math is going to require you to do. It's not hard. I have the calculator steps up at the top. So if you forget them, they're going to be right here. So go ahead, moving on to this next page. I'm going to show you how to do this in the calculator. Again, super easy. You just have to read, okay? All right. Number 1, Cody's favorite snacks are pecans and almonds. The Nut House sells pecans for $2 a pound and almonds for $4.50 a pound. He wants to buy a mixture of them that weighs 6 pounds. He has $15.25 to spend, and he uses the system below to determine the number of pounds of pecans and almonds he can buy. So this guy right here, that's your equation that you're going to be using. Now, again, you cannot graph this. One reason you can't graph it is A, it's not in Y, it's not in our Y and our X. So it has P and it has A. So we want to make sure we're not graphing it because we can't graph those different letters. Also, we don't have Y by itself. So if we were to try to graph this in our calculator, it's not going to work because it's not in slope-intercept form. So I don't want you to use that. I want you to use your calculator page. So here's how this is going to work. Go to your TI Nspire. And again, this is the same for the kids that are in my class. You're going to click add and you're going to click calculator page. Everybody click calculator page. Promise you it's super duper easy. The next thing you're going to do is you're going to click on the wrench button. You're going to go to algebra. And then you're going to go to solve systems of linear equations. Now this screen should pop up. And here's what we're going to change. It says number of equations. We have 2 equations. And then it says variables. Our variables are not X and Y. So we're going to click on those and we're going to delete them. Instead, we're going to use the letters P and A. Make sure you separate them by commas. Using the letters P and A. We're going to click OK. Now, 2 boxes are going to appear on your calculator. The first box is for your first equation. So you're going to type that in. 1525 equals 2P. Make sure you do lowercase. Plus 450A. You're going to scroll down to the second one. You're going to type in 6 equals P plus A. Then you're going to click enter. Give me a thumbs up once you got that.